Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is June 2018, Paper 1, Higher Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Welcome back to another past paper walkthrough. I'm starting on the June 2018 series of papers here. We're looking at paper 1. It's actually dated the 24th of May 2018. So let's get cracking. Question 1. Work out the cube root of 64 times 1000. Now I could multiply those two things together. It's not going to help me very much here, is it? Now I would suggest for your exam, for your non-calculated paper, that you do remember the first 10 cube numbers, so you're able to answer questions like these without too much trouble. So let's have a look at this. When you've got a root, you can easily break it down into separate roots. So the cube root of 64 times 1000, I can break up into the cube root of 64 times by the cube root of 1000. And because I know the cube roots for the first 10 numbers, I know that the cube root of 64 is 4, and I know that the cube root of 1000 is 10, and 4 times 10 is 40, so it's that one there. So like I say, if you memorize the first 10 cube numbers, I think it would be really useful for the non-calculated paper. Question 2. The vector negative 2, 3 translates A to B. Okay, so what does the vector negative 2, 3 look like? Vector is always given the form x over y, so that means I'm going negative 2 in the direction of x, or like 2 units to the left and 3 units up, so 2, 3 like that. So we're going to end up with an arrow from this point down here, which could be A, and up to that one there, which is B. Now if I flip it around and I want to go in the other direction, so instead of going from A to B, I'm going from B back to A again, I'm going to go the opposite direction, aren't I? So rather than going 2 to the left, I'm going to be going 2 to the right, and rather than going 3 up, I'm going to go 3 down. So that as a vector notation is going to be 2 to the right is just 2, and 3 down is negative 3, so it's going to be 2, negative 3. It's that one there. Question 3. Circle the expression that is equivalent to 3a minus a times 4a plus 2a. Okay, so we've got to collect some like terms together, and also we need to remember BIDMAS. BIDMAS says brackets, indices, division, multiplication, addition, subtraction, which means we have to do the multiplying first. So we've got to deal with that bit there, haven't we? Okay, so what's a times 4a? A times 4a is 4a squared. Okay, now if you look at it, we've got two types of terms. We've got terms in A, and we've got a term in a squared, which we can't add to our A terms. So collecting the a terms together, my 3a and the 2a is going to give me 5a, and it's going to be 5a subtract 4a squared, which I can't combine any more than that. It's that one there, look. Question 4. Circle the number that is closest in value to 9.8 divided by 0.0195. Okay, so I've got some various choices. So basically I need to work out the magnitude of this number really. They're all going to begin with 5. So let's round off these two numbers to one significant figure and then see what we get. So 9.8 to the nearest whole number is 10. And the first significant figure of the next number, look, is that one there, isn't it? So I'm going to round up to the nearest hundredth. So that is going to be 0.02 to one significant figure. So I've got 10 divided by 0.002. Now multiplying through, so dividing through by decimals is not so easy. What about if we times top and bottom by 100 to start off with to get rid of that decimal? So 10 times 100 is 1,000. And 0.02 times 100 is 2. So that is equivalent then to 100 over 2. Sorry, 1,000 over 2, and 1,000 over 2 is 500. It's that one there. Question 5. Solve 5 lots of x plus 3 is less than 60. So this is an inequality. Now you can just solve these exactly the same way you would an equation. So as long as you can solve equations, you can also solve inequalities, mostly. There is one extra rule, but we'll get to that in a minute. So 5 lots of x plus 3 is less than 60. I can simplify both sides by dividing through by 5. So dividing the left-hand side by 5, that's going to cancel with that. It's going to leave me with x plus 3 is less than. And then 60 divided by 5 is 12. And then subtracting 3 from both sides, then I'm going to be left with x is less than 9. Okay, so like I say, you can solve these exactly as you would an equation. Just one thing to be careful of is dividing through by negative numbers, because that flips the sign round if you do that. So either avoid dividing through by negative numbers, or remember that if you do, you'll have to flip the inequality sign round the other way. Question 6. The height of Zach is 1.86 meters. He's a big boy. And height of Fred is 1.6 meters. Write the height of Zach as a fraction of the height of Fred. Give your answer in its simplest form. Write the height of Zach as a fraction of the height of Fred. That means Zach's height goes on the top and Fred's height goes on the bottom. So it's going to be 1.86 divided by 1.6. Now again, we've got decimals here, which we can easily get rid of by multiplying top and bottom by, well, let's do it by 100. So what will that give me? That will give me 186 over 160, won't it? So it's a top-heavy fraction. Right, so we're looking for common divisors now. 160 and 186. Wow. Struggling to find a common divisor. Bigger than 2. Let's just halve it and have another look. So that would be 93 over 80. Okay, any common factors there again? 3, no. 7, nope. No, I can't think of any more. No, I think that's about as far as I'm going to get with cancelling down. Now it's asking for the simplest form here, so we've cancelled down as far as we can. Now we could write it as a mixed number. We could write it as 1 and 13 over 80. But I don't actually think that is any more simple than this. I prefer to leave my answers as top-heavy fractions. I think they're more useful, so I'm going to leave it like that. Question 7. The point A, which has coordinates 0, 2, and the point B, which has coordinates 6, 5, are points on the straight line A, B, C, D. We're told that AB is equal to BC, which is equal to CD. So let's just mark that on the diagram. So these are all the same length, aren't they? These three sections. Work out the coordinates of D. Okay. Right, so we know coordinate A and we know coordinate B, so we can work out how far in that direction and how far in that direction is between those 2 points. So having a look at the x coordinates, 0 to 6 tells me that the distance in the direction of x is 6. And looking at the y coordinates, 2 and 5, tells me that the distance in the y coordinates, 5 subtract 2, is 3. So from A to B we're going 6 units along and we're going to go 3 units up. Okay, now we want to work out the coordinates of D. So we can either work out C along the way by going 6 along and 3 up and another 6 along and 3 up, or we can double that up and go 12 along and 6 up. Okay, I'm going to do it in one jump because I'm a bit lazy. Don't want to do things twice. So 12 along and 6 up from B. So B has coordinates 6, 5. So if I go an extra 12 along in the direction of x, then 6 plus 12 is 18. And if I go, I'm at 5 in the direction of y, and if I go up another 6, then that's going to be 5 plus 6, that's going to be 11 up. Okay, giving me coordinates 18, 11 for D. Okay, as I say, I could have done it in 2 jumps gone by C, but 18, 11. I think that's a slightly quicker way of doing it. Question 8. A coin is thrown 50 times, it lands on heads 31 times. Write down the relative frequency it lands on heads. Okay, well, relative frequency is defined to be successful trials. Successful meaning the thing that you're looking for happens. Divided by total trials, so how many times you tried it all together. So successful trials over total trials. So here it landed on heads 31 times. So in terms of this problem, we had 31 successes and we had 50 trials altogether. So the relative frequency is 31 over 50. Don't be under any pressure to simplify probability questions. You never get any more marks for it. You just might as well leave it as it is. I'm not actually sure you can cancel it down, can you? Anyway, let's move on. 8b, Raj says the coin is biased towards heads. Use the data to give a reason why he might be correct. Okay, well, we've got 31 out of 50 trials that were heads, which is a bit more than you would expect, wouldn't you? The theoretical probability of getting heads is a half, so the expected successes would have been a half times 50 or 25, and he's reporting 31 here. Okay, so we would expect 25, but he got 31. Okay, so that is some evidence to suggest it might be biased. It might just be a lucky break though. It's not that far off 25, is it? But anyway, that's what we can write down. Question 9. The range of a set of numbers is 15 1/4. The smallest number is -2 7/8. Work out the largest number. So range, if you remember, is defined to be the largest value minus the smallest. So if we rearrange that, move that over there, look, then the largest value is going to be the range plus the smallest, isn't it? So I'm going to find it by adding my two fractions together. So in this case, it's going to be my range, which is 15 1/4, plus my -2 7/8. And now adding a negative is the same thing as taking away. So that is the same thing as those two things subtracted from each other. I'm just going to write them as top-heavy fractions now as well. Should I do that? Yeah, let's do that. So 15 fours are 60, plus 1 is 61 quarters. So I've got 61 quarters minus 2 eighths are 16 plus 7 are 23, so 23 eighths. Okay, so subtraction, I need a common denominator, so just doubling up those two numbers there, so we change it into an equivalent fraction over 8. So 61 times 2 is 122 eighths. So 122 eighths minus 23 eighths. So subtracting numerators, that's going to give me 99 over 8. Do we have to give it in a certain form? Just says work out the largest number. Got 99 over 8. Shall I write as a mixed number? Well, 8s into 99 go 12 times, don't they? 12 eighths are 96. So it goes in 12 times, remainder 3. So it's 12 and 3 eighths. Again, I think 99 over 8 is probably a more useful number to deal with and would still get you all the marks, I think. Doesn't say right as a mixed number, but either of those will get you the 3 marks. Question 10. Y is inversely proportional to x. Complete the table. Okay, so y is inversely proportional to x. That means y is inversely proportional, little fishy, over 1 over x. Okay, so that's what that is saying mathematically. Now we can replace the little fishy symbol with equals k. So I'm going to rewrite that. So y equals k over x, where k is a constant that we can then find. Okay, now you can find the constant k if you've got two values, well, your value of x and your value of y that go together. Now we've got one of those in the table. If you look at this table, I've got two numbers here that go together. When x is 6, y is equal to 4. So sub in x equals 6, y is equal to 4 into my partial equation, y equals k over x. I should be able to find out what k is. So that becomes 4 equals k over 6, replacing y for 4 and x for 6. Okay, then just taking that 6 there, cross multiplying up there, or multiplying both sides by 6 if you'd rather, I'm going to get k is equal to 24, aren't I? Okay, so my complete equation then is going to be y equals k, which we've now found to be 24, over x. Okay, so now this is my complete equation, which I can then go and find my other values. So if x equals 12, then y is 24 over x. Y is 24 over 12. 24 divided by 12 is 2. So when x is 12, y is 2. And what about the other way around? So if y is 8, what is x? Okay, so if 8 is equal to 24 over x, just cross multiplying these two, just switching them around, I'm going to get x equals 24 over 8. 24 divided by 8 is 3. So x is 3 when y is 8. Once you've done a few of these proportional questions, they get very, very formulaic. They always start off by giving you the rule that links y and x. You can then form your partial equation, which involves the constant k, and then you'll have a pair of values that you can sub in to find what k is to complete the equation, and then you can go on and use your complete equation to find other values. They're always the same, very, very formulaic questions, and after you've done a few, you should be good on them. Question 11. A large rectangle is made up by joining 3 identical small rectangles as shown. Now, it's not drawn accurately, so don't get your ruler out. We're told that the perimeter of one small rectangle is 15. Work out the perimeter of the large rectangle. This looks like a job for algebra. Now let's say that the width of one of these rectangles is w. Now I could write L there for the length, but actually if you look at it, this length here is the same thing as this and this together. In other words, we've got a rectangle which has got sides W and 2W. So I only need one unknown for this rectangle, not two. So I've got a rectangle with sides W and 2W. So then its perimeter is going to be those four sides added together. So my 2W plus my W plus my 2W plus my W going around the rectangle 2W, W, 2W, 2W. So how many W's is that then? That's 6 W's altogether. And we're told that the perimeter of the small rectangle is 15. So we can replace the P there with the 15. And that tells me that 6W is equal to 15. So dividing both sides by 6, I'm going to get W equals 15 over 6. So 6 goes into 15 twice, remainder 3. So W is 2 and 3/6, or 2.5, isn't it? 2.5. Now, the question actually wants us to work out the perimeter of the large rectangle. So if we come back to our diagram then our large rectangle is going to be, from here to here, is 3 W's, isn't it? It's 2W and a W, which is 3 W's. And then down here is 2 W's. So it's 3W, 2W, 3W, 2W, which is 10W, isn't it? So the perimeter of large rectangle equals 10W, which is equal to, well, it's 25. So the answer is 25 centimeters. Question 12. Put these numbers in order from smallest to largest. Okay, and I've got some numbers that are written in standard form. They've got negative indices, so they're kind of decimal numbers, aren't they? Okay, so I've got 8 times 10 to the minus 4. Let's just write that as a decimal. That's going to be 0.0008. Okay, if it's minus 4, I'm writing 4 zeros. 0.0008. 4 times 10 to the minus 2. Again, I've got minus 2, so we're going to write 2, 0, 0.0, and then put the 4 in. 6 times 10 to the minus 4. Going to write 4 zeros. 1, 2, 3, 4. And then the 6. And then I've got my number there, 0.07 on the end. Okay, now these numbers have got different number of digits. Sometimes it's handy just to kind of pad them out so they're easier to compare. And then you can kind of compare them like numbers. So I've got 6, 8, 400 and 700. It makes them very easy to compare. So the smallest then is going to be this one. So I'm going to write that one first. Then my next biggest is going to be this one. My next biggest is going to be this one. And my largest one is this one. Okay. Now I'm going to put them in order, and I'm going to write down the numbers that I was actually given, because they're the ones I was asked to compare. So my smallest is 6 times 10 to the minus 4. My next biggest is 8 times 10 to the minus 4. My next biggest is 4 times 10 to the minus 2. And then finally, I've got 0.07. Question 13. Circle the volume that is the same as 15 cubic centimeters. Now, first off, 1 cubic centimeter, what is that in terms of cubic millimeters? How many cubic millimeters in a cubic centimeter? Okay, well, you know that there are 10 millimeters in a centimeter. So if you had a cube where all the sides were 1 centimeter, then in millimeters that would be 10, 10, and 10, wouldn't it? 10 times 10 times 10. And 10 times 10 times 10 is 1,000. So there were actually 1,000 cubic millimeters in a cubic centimeter. So that is our conversion rate then, isn't it? So if I want to go from 15 cubic centimeters into millimeters, cubic millimeters, I need to multiply through by 1,000. So 15 cubic centimeters is 15,000 cubic millimeters. That one there. Question 14. Patterns are made using straight lines and arcs. Part A says pattern A and pattern B consists of 1 row and 2 rows. More rows are added to pattern B so that the number of straight lines to the number of arcs is 10 to 9. How many rows are added? Interesting question. Let's have a look at what we've got to start with. It's a very curious question. I've not seen one like this before. Okay, so we've got straight lines and arcs. So lines to arcs in this first pattern, I've got 1, 2, 3, 4, 5 lines, and I've got 1, 2, 3, 4, 5, 6, 7, 8 arcs. So the ratio of that first one is 5 to 8. Okay. In my second one, I've got 5 more lines, haven't I? So that doubles up to 10. And then arcs, I've got 1 extra row, so 4, 8, 12. It goes from 10 to 12. Okay. So my sequence then is of pattern A, or 1 row, to pattern B is 5 to 8 goes to 10 to 12. Now 10 to 12 cancels down, and I think our 10 to 9 will cancel down. That'll be the cancel down value. I think what we're going to do is we're going to go through this sequence until we find one that is in the ratio of 10 to 9. Okay, so from basically every time we add another pattern onto this, we are going to be adding 5 more rows, aren't we? So each time we add one, we're going to be adding 5 more. This is a +5 sequence. And in terms of the arcs, we're adding 4, aren't we? So this is a +4 sequence. So basically we've got 2 linear sequences running next to each other. The first sequence is going up in 5s. So it's going to be 5, 10, 15, 20, 25, 30, and so on. And on the other side, it's going up in 4s. So it's going to go 8, 12, 16, 20, 24, 28. Okay. So we're looking for the one that has a ratio of 10 to 9. Oops. So we're looking for one that has a ratio of 10 to 9. Are we there yet? Don't think so. I think we're going to have to go on a bit further, aren't we? So the next one is going to be 35, 40, 45. This one is going to be 32, 36, 40. I think that one was promising. Divide both sides by 5. That's 9 to 8. So that's not quite right. What about that one above it, though? What about if I divide that one by 4? That one is going to be 10 to 9. It's actually that one there, isn't it? So, which number in the sequence? How many rows are added? How many rows are added? More rows are added to B so that the number of straight lines to the number of arcs. Okay, so how many do we have to add on to B? These are the ones we added here. How many are they? 1, 2, 3, 4, 5, 6. We added 6 more rows to B. Part B says a different pattern is made using 20 straight lines and 16 arcs. The straight lines and arcs are made from metal. 20 straight lines cost £12. Cost of one straight line to the cost of one arc is 2 to 3. Work out the total cost of the metal in the pattern. So we've got lots of ratios all going on at the same time here, aren't we? So what have we got? Then we've got ratio of lines to arcs is 20 to 16. The straight lines and arcs are made from metal. 20 straight lines cost £12. Okay, so we know that the cost of the lines is £12 for 20. So if 20 straight lines cost £12, then how much does one cost then? Dividing 12 by 20. Well, dividing it by 10 is 1.2. So divided by 20 is 0.6. It must be 60 pence then per straight line. And we know that the cost of straight lines to the cost of arcs is in the ratio of 2 to 3. So if lines cost 60, then how much do arcs cost? Well, if it's in a ratio of 2 to 3, then the arcs are going to cost half as much again, then, aren't they? They're going to cost 90 pence. So each arc is going to cost 90p, and each straight line is going to cost 60p. Well, we know all 20 cost 12, so now we need to know the cost of the 16 arcs if each arc is worth 90 pence. So what is 16 times 0.9? Okay, well, 16... Well, a tenth of 16 is 1.6, and 16 take away 1.6 is 15, 14.4. So they are going to cost £14.40 then, isn't it? Okay, so what's the total cost of the metal? Then the total cost of the metal is going to be £12 plus the 14.40, which is £26.40. 26.40. Now that was a very horrible question. A lot of you have to be quite careful thinking that one through, I think. But we got there in the end. It's £26.40. Question 15. A biased dice is thrown. Here are the probabilities of each score. So you can get 1, 2, 3, 4, 5, or 6 on this dice, 6-sided dice. And these are the various probabilities. So you can see that it's much more likely to land on 1 than it should. Quite crazy, actually. No, most likely to land on a 5, then a 1, and then a 6, and then a 3, and then a 2 and 4, at least likely. So the dice is thrown 200 times. Work out the expected number of times. The score will be odd. Okay. So the probability of getting an odd number is going to be the probability of 1 or 3 or 5, which is the probability of 1 plus the probability of 3 plus the probability of 5, which is 0.25 plus 0.15 plus 0.3. So adding all that up, 0.25 plus 1.5, what's that? 0.4, and plus 0.3 is 0.7. So that adds up to 0.7. So our expected number of outcomes is going to be equal to our probability of success, 0.7, times our number of trials, which is 200. So what's 0.7 times 200? Well, that is the same thing as 7 times 20, which is 140. I'd expect it to be odd 140 times. Now you could have just as equally have worked out the number expected numbers of 1 and the expected number of 3 and the expected number of 5 and added them up. That would also work, but I think this way is slightly quicker. Question 16. The value of y is 20% more than the value of x. Circle the ratio of x to y. Okay, so the value of y is 20% more than the value of x. Now let's say the value of x is 100, just giving it a value. And then, so that would make the value of y 20% more than 100, which would be 120. So therefore, the ratio of x to y would be 100 to 120. which cancels down to 10 to 12, 5 to 6. It's that one, isn't it? Question 17. Here is a triangle. It's not drawn accurately, and we're asked to circle the correct equation. So these are all kind of formulations of the sine rule, aren't they? So what does the sine rule say? The sine rule says sine A over A equals sine B over B is equal to sine C over C, or the other way up, that A over sine A equals B over sine B, which equals C over sine C. Now we are wanting to find x here, aren't we? So we want the bits with x at the top. Now x is a side, so we're going to write it down with x is on the top, or the lengths on the top, and the angles on the bottom. Now side x is opposite angle 42. Angle 34 doesn't have a side opposite it, so that one is no good. 15 is opposite 104. Okay, now the sine rule is all about these opposite pairs, so you need to have two pairs of opposites, an opposite side and an angle. Okay, so I can see that x is opposite the angle 42, and I can see that the 15 is opposite the angle 104. So I'm going to write it down using the sides on the top, so like a over sine A equals b over sine B, that way around. Okay, and then so let's sub in for x. So putting my x on the top over the sine of the angle opposite to x, which is sine 42, and that is going to be equal to, and then writing down my other pair, my 15 over sine 104. Okay, so opposite pairs, that one goes with that one, and that one goes with that one. And my x over sine 42 is that pair, and my 15 over sine 104 is over that one. That one didn't come out very well for some reason. So which one is that? Oh look, it's that one there. Question 18. Here is a tunnel for a toy train. So it's a kind of prism, isn't it? So you've got a uniform cross section running all the way through for a certain length. Okay, whatever the length here, and then this is the cross section, so it's a prism. Okay, now the diagram below shows the cross section of the tunnel. AD is semicircular arc of radius 10, and BC is a semicircular arc of radius 7, and the length of the tunnel is 30. Work out the total area of all 6 faces of the tunnel. Give your answer in terms of pi. Oh, so they want the surface area here, not the volume. That's going to be fun. So it says there are 6 faces. It tells us in the question. Where are those 6 faces? Okay, well, we're going to have this front face here, aren't we? Which is going to match up with a similar back face at the end there. It's going to be exactly the same. Then where are the other faces? Well, we're going to have this kind of curved side here that goes all the way around the top. But then we're also going to have another one inside, if you see what I mean. Now when you straighten that out, that's actually going to be a rectangle, isn't it, that wraps all the way around there. And then we've got kind of its feet. So these feet part here and another one there, look, so they're going to match up. So those two are going to be the same. So the front face is going to be the same as the back face. Those 2 feet are going to be the same. And then we're going to have 2 different size rectangles that are wrapped around the inner and outer part. They look curved there, but when we straighten them out, they're going to be rectangles, aren't they? Okay? Does that make sense? So this is quite a long question. Well, we're going to have to get stuck in. Let's get busy with it then. So let's start with this bit here then. Okay, this kind of C-shaped part. So that is going to be half of a circle with a smaller circle cut out of the middle, isn't it? So it's going to be half of like the big circle, which I'm going to get with pi r1 squared, take away the smaller circle in the middle, pi r2 squared, okay, which is going to be half of, well, the bigger radius is this one here, isn't it, 10, and the smaller radius is this one, 7. So it's going to be half of, I'm just going to factorize pi out as well, out of that bracket. So I'm going to get r1 squared minus r2 squared. So r1 is 10 squared, r2 is 7. So it's going to be pi times 10 squared minus pi times 7 squared. So I'm factorizing the pi out. So I've got pi over 2 times 10 squared is 100 minus 7 squared, which is 49. So that's 100 subtract 49, which is 51, isn't it? So it's going to be 51 pi over 2. I'm going to leave it in terms of pi for now. Well, I'm going to have to because I haven't got a calculator. So it's 51 pi over 2. Now the back face is also going to be 51 pi over 2 because it's identical to the front part. Okay, so we're doing well. We've got 2 done already. Right, now what about the green bit then? Like the outer rectangle. Now, let's say that is a rectangle, isn't it? And this part of the rectangle is this side here. Okay, so it goes all the way around. It's the half the circumference of that bigger circle, isn't it? So that distance is half the circumference of the bigger circle. So the bigger circle has got a radius of 10, which is a diameter of 20, so a circumference of 20 pi. So it's going to be pi times the diameter, and then we're going to halve it, aren't we? Pi times diameter over 2, which is 20 pi over 2, which is 10 pi. Yeah, and then the length of the tunnel was 30 centimeters. So from here to here is 30, and from there to there is 10 pi. So then the area of that bit then is going to be 30 times 10 pi, which is going to be 300 pi. Okay, so the green part is 300 pi. We're getting there slowly. So what about the blue part? Okay, so that's the other curved surface, and it's made up of a rectangle again. This time the rectangle distance around here, this bit here, is going to be half the circumference of the smaller circle. So if you remember, the smaller circle had radius 7, so it has diameter 14. So again, it's going to be half pi d, half the diameter, half the circumference of the smaller circle, where here the diameter is 14. So it'd be 14 pi over 2, which is 7 pi. The length is still the same, it's still 30. So then the area of that rectangle is going to be 30 times 7 pi, which is 210 pi. Okay, so doing well. We've got 4 out of the 6 sides done now. Finally, we've got 2 matching rectangles which make up the feet of this shape. It's these rectangles here, look. Okay, now that is going to be another rectangle shape. This time the rectangle is going to have a length of 30 again. Would have been easier just to work. No, it wouldn't have done. Well, I'm doing fine. So, okay, so it's got to have a length of 30, and what is the width? The width is going to be the difference between these two radiuses, isn't it? From there to there was 7, and from there to there is 10. Oh, it even tells us it's 3. Okay, so it's just going to be 3. So it's going to be 3 times 30. 3 times 30 is 90. No pies for this one, it's just a rectangle. Okay, and then obviously the other one there is also 30. That one in there is going to be 30 as well. Okay, so what are my 6 faces then? So then the total surface area, I'm going to add those 6 things together. So I'm going to have 51 pi over 2 twice. So it's going to be my 51 pi over 2 and another 51 pi over 2. That's the kind of that bit. Then I've got my 2 feet, which are 90 and 90. Plus 90 and 90. And then I've got my big rectangle, which was 10 pi. No, it wasn't. It was 300 pi, and my small rectangle, which was 210 pi. So plus 300 pi plus 210 pi. Okay. So 51 pi over 2 plus 51 pi over 2 is just 51 pi, isn't it? So that's 51 pi. And adding that to my 300 and my 210 pi. 300 and 210 is 510 plus 51 is 561. 561 pi plus 90 and 90 is 180. So that is my final answer, 561 pi plus 180. Now that was bags of fun, wasn't it? Question 19. Type A batteries and Type B batteries were tested. The cumulative frequency diagram shows the information about the battery life of Type A. And we can see it's got one of those distinctive S-shaped cumulative frequency curves. Estimate the interquartile range for Type A. Okay. Now you can see that we've got altogether, we've got 80 batteries in this sample. Okay. Now the interquartile range is the middle half of your data. So basically you need to look at the range between 1/4 and 3/4 of the way through your data set. So 1/4 of 80, 80 divided by 4 is 20. So we're going to read across from 20 to the graph. So from 20, I'm going to read across to the curve and then switch down, and that will be our Q1 value. Not drawn along the ruler particularly well today. What's going on? Okay, now it's done it. So, and then 3/4 of the way through the data is going to be reading across at 20 times 3, 3/4. It's going to be at 60. It's going to be easier. Okay, and then when we hit the curve, we're going to switch and draw down. So my Q1 is there. Look, that's Q1. Lower quartile. My upper quartile is here. That's Q3, which is 3/4 of the way through. Q2 is the median. So Q1 is lower quartile, Q3 is the upper quartile, and then the interquartile range then is the distance between those. Interquartile range, which is Q3 minus Q1. So from my graph I can see that Q3 is 1400 and Q1 is 1100, and 1400 minus 1100 is 300. Question 19b. Estimate the number of type A batteries that had a battery life of more than 1600 hours. Okay, let's go back and look at the graph. More than 1600 hours. Well, 1600 hours on my graph is here, look. So we're going to use our community frequency curve the other way around this time. So rather than reading across from the frequency and down, we're going to read up from 1600 until we hit the curve, and then we're going to change direction and read across. Okay. Struggling to draw on this line today. Go on, stop being annoying. Okay, done it. Right, so what's that value there then? That reads to me like 76. So up there is 76. Now what does that tell me though? That tells me that 76 batteries had a battery life of 1600 hours or fewer. Okay? Now the question didn't ask me that, it asked me how many batteries had a life bigger than 1600. So it's not the 76 as my answer, it's my difference between 76 and the top, which is 80. So the difference between 76 and 80, those batteries had a life longer than 1600 hours. So it's going to be 80 subtract 76, which is 4. So it's going to be 80 subtract 76, which is equal to 4 batteries. Okay, now part C says the box plot shows information about battery life of type B. On average, which type had the greater battery life? Tick the box. Well, the greatest battery life is going to be given by the median right here, I suppose. So it's like the average life expectancy. So here the median is the Q2 value. It's the one in the middle of your box plot, and if you read down you can see that it's 1300. So type B has a median value of 1300. So let's compare that with the median value for type A then. Going back to the graph. Now we didn't work out the median, we worked out the lower and the upper quartiles. Now we can find the median by looking across from halfway through the values. So again, reading across from 40. Ruler, what's up with you? Okay, it's drawing again now. And then switching around and drawing down. Okay, I can see my Q2 value or median is there. So I read that to be what, 3 out of 5 little squares up from 1200. So if there are 5 little squares between 1200 and 1300, which is a span of 100, then each little box is worth 20, then, isn't it? 20, 40, 60, 80, 100. So 3 little boxes is going to be 60. So I read that off as 1260 as the median value from type A. So we said that type B has a median of 1300 and type A has a median of 1260. So B is the biggest medium, isn't it? So what do we have to tick? On average, which type has the greater battery life? B does. State how I chose my answer. Well, I've shown that. That's all fine. I've done everything. Question 20. A linear sequence starts A plus 2B, and then A plus 6B, then A plus 10B, and so on. The second term has value 8. The fifth term has value 44. Work out the values of A and B. So it's kind of an interesting question. So it's chucking in simultaneous equations in with sequences and a little bit of algebra. It's lovely. Okay, so you can see from one term to the next, what is the term-to-term rule? I've got A plus 2B, and now I've got A plus 6B, which is 4B more. So I'm adding 4B each time, and again, there we can see I've gone up by another 4B. So my next two terms then are going to be A plus 14B and A plus 18B. Now I'm told in the question that the second term has value 8. So this one was worth 8. And the fifth term has value 44. So this term here is equal to 44. So what I've got then is a pair of simultaneous linear equations in A and B. So this term here, look, gives me that A plus 6B is equal to 8. And this one here gives me A plus 18B is equal to 44. Okay, so that's equation 1, equation 2. Now we're going to subtract one from the other, aren't we? I'm just going to subtract uphill. So equation 2 subtract equation 1. So A subtract A, they cancel each other out. 18B subtract 6B, that's given me 12B. And 44 subtract 8, that is equal to 36. Okay, so I've got 12b is equal to 36, dividing both sides by 12, or cross multiplying 12, whichever way around you do it, gives me b is equal to 3. Okay, now I've got b, I can work out a, can't I? So let's sub that back in. So then substitute b is equal to 3 into, could be either one. I'm going to go for the simple one. I'm going to go for equation 1. So substitute b is equal to 3 back into equation 1. That tells me that a plus 6 lots of 3 is equal to 8. Well, that is a plus 6 3 is 18. A plus 18 is 8. Change sides, or subtract 18 from both sides, whichever way you want to think about it. A is going to be 8 subtract 18, which is negative 10, isn't it? Okay, always good to check. You've got another equation that you can check with. So I've got, in the second equation, I've got a plus 18b. A plus 18b is 44. Is that true if I sub in my two values that I found? So if I sub in minus 10 for a and 18 lots of 3, is that equal to 44? Well, 18 threes, 18... Well, 3 20s is 60, so 3 18s is 54. Take away 10 is 44. Yeah, that is true. So it works. So it's always good to check in the exam if you can. Much better to check it here and make correct any mistakes then after you've finished, because you can't then. So A is minus 10 and B is 3. Job done. Question 21. Enlarge triangle ABC by a scale factor of minus 2, center for 1. Okay, so the triangle's already drawn and the center of enlargement is also drawn. What we need to do is find the image points of A, B, and C. Now, when you've got a negative scale factor, your object and image are going to appear on opposite sides of the center of enlargement. Now, it might be handy to draw ray lines on. So ray lines are lines that pass from each of your points through the center enlargement and then out to your image points. So there's my first ray line. That's my next one. Kind of like guidelines. And then finally, 1 through B in the center. Okay. Right, so let's take each point in turn. So my centre of enlargement is here. It's got a bit obscured by my lines. Then my point A is here, which is 1, 2, 3, 4 units to the right of my centre of enlargement. Okay, and I'm going to multiply that by a scale factor of -2, which means that it needs to be -8 units from that centre, or 8 units the other way. So counting 8 units in the opposite direction, 1, 2, 3, 4, 5, 6, 7, 8, it ends up there. So that is going to be my point A dash. Okay, so that's A dash. So we're going to do the same thing with B and C. Now if you look at B, B is kind of 1 unit below and 2 units to the right of the centre of enlargement. So I'm going to multiply that by a scale factor of -2. So rather than being 2 below, it's going to be 2 times 2, 4 above. So it's going to be 4 units up from the centre of enlargement. And rather than being 2 units to the right, it's going to be 4 units to the left. And you should find it lands on one of your ray lines. So that point there is my point B dash. Okay, and then C, the same thing. That is 2 units below and 3 units to the right. So multiplying that by a scale factor of -2, it's going to be 4 units above and 6 units to the left. 2, 4, 6 puts it here. Again, it should fall on one of your ray lines. That is C dash. Okay, once you've got your shape, you can join up with a ruler. Okay, all done. Question 22. Which of these represents the shaded region? Circle your answer. So A intersect B dash. Let me just draw a quick sketch of what each one of these are. That is the union of everything in A intersects with things not in B. Okay, so that is just going to be that bit there. Okay, inside A but not in B. That's A intersect B dash. B dash, the complement of B, is everything outside B. So that's going to be this bit outside plus this bit in here. So that isn't it either. It's close, but it's the middle bit that's different. A union B dash is everything inside A union with everything outside B. So everything inside A, so that is all that bit, union with everything outside B, which adds this bit on here. So I think it's that bit there, isn't it? It is that one. So what's A dash union B dash? Everything outside A union with everything outside B. Well, everything outside A is everything outside of that circle, and everything outside B is everything outside of that circle. So everything outside either circle is going to be kind of everything bar the bit in the middle then, isn't it? It's going to leave you that little bit in the middle. Okay, so yeah, it's that one there, A union B dash. Question 23. A shopkeeper compares the income from sales of a laptop in March and April. In April, the price was 1/5 more than the price in March, and the number of units sold was 1/4 less than the number sold in March. By what fraction does the income from these sales decrease in April? Okay, so we're not sure what the price is here or the number of units sold. So let's just say that in March the price was 1 and the number sold was 1. So then in April it's going to be 1/5 more than in March. So that is 1 plus 1/5, which is 6/5. So the price is going to be 6/5 in April. And the number sold is going to be 1/4 less. So if you've got a whole one, you take off 1/4, you're left with 3/4. So by what fraction does the income from these sales decrease in April? So in March, if the price is 1 and the number sold is 1, then 1 times 1 is 1. So if we can multiply these two fractions together, then we'll know what the fraction of what we had. We'll know the fraction of April compared to March, and therefore we'll know, well, we can then work out what the decrease is. So anyway, let's just multiply these together. 6/5 times 3/4. Let's first divide that by 2 and that by 2 to make the maths a little bit easier. So 3 3s are 9 and 5 2s are tenths. So we've got 9 tenths. So April is, so 1 times 1 is 1. 6/5 times 3/4 is 9 tenths. So by what fraction does the income from these sales decrease in April? It decreases by a tenth. So that is a decrease. Can't spell decrease. Decrease of 1/10. Question 24a. Work out the value of 2 to the power of 14 divided by 2 to the power of 9, all raised to the power of 2. Okay. Give your answer as a fraction in its simplest form. Okay, so let's just write it as a fraction to start with. And I've got 2 to the power of 14 divided by 2 to the power of 9 raised to the power of 2. Okay, so let's just deal with those brackets on the bottom first. I've got 2 to the power of 9 raised to the power of 2. It's an index of an index. So what I need to do then is multiply these two numbers together. So it's going to be 9 times 2, give me, 9 times 2 is 18. So that's going to give me 2 to the power of 14 divided by 2 to the power of 18. Okay, then I've got two numbers with the same base, so I just need to subtract the indices. So that's the same thing as 2 to the power of 14. Subtract 2 to the power of 18, which is 2 to the power of minus 4. And 2 to the power of minus 4 is just 1 over 2 to the power of 4 then, isn't it? So I've got 1 over 2 to the power of 4. 2 to the power of 4 is 2, 4, 8, 16. So it is 1 over 16. Part B says, work out the value of 25 to the power of 3 over 2. So I've got a fractional index here. Now you can treat these as two separate operations. I'm going to be cubing, and I'm going to be finding the square root of my number. Okay, so I'm going to have 25. I'm going to square root it, and I'm going to cube it. I like to do the root in first because it ends up with smaller numbers. So the square root of 25 is 5, and 5 cubed is 125. So 1, 2, 5. Question 25. Here is a sketch of the graph of y equals the cosine of x for values of x between 0 and 360 degrees. Now we're told that cos x equals cos 60. Work out the value of x when 90 is less than or equal to x, which is less than or equal to 360. Right, so you should remember your exact values for the cosines of 0, 30, 45, 60 and 90, along with the sines and their tangents. I'll just pop up the whole table for you to have a quick look at now. You need to remember these for your paper ones. You're expected to know all these values. So anyway, I can see from this value, I should already remember, that the cos of 60 is a half. Okay, so cos 60 equals a half. So if I'm at 60, then the cos of 60 is a half. There, look. Now if I put on my ruler at a half, and read across, you'll see that there's more than one value though that has a cosine that ends up being a half. What's up with my ruler today? It's gone really wonky. Okay, so if I get to the curve again there and draw down, you'll see that there's a second point that also has a half as its cosine, and it's that angle there. Now that is 1 to a third of the way between 270 and 360. It's going to be the angle 300. Okay, so the cosine of 60 is a half, but also the cosine of 300 is also a half. So what is the value of x when x lies between 90 and 360? It's going to be that one. It's going to be 300. Okay, part B says cos x equals negative cos 60. Work out the values when x lies between 180 and 360. Well, negative cos 60 is a half, so negative cos 60 is negative a half. So now we need to look along our graph at negative a half. Here's negative a half, halfway between 0 and 1. Again, if I draw a line from negative a half, you can see it intersects my graph in two places. Come on, ruler, sort it out. Okay, there. So my first one is here. So that's 30 more than 90. That one's at 120, isn't it? So that's 120. And I've got another one here, which is 30 less than 270, which is going to be then 240 degrees. Okay, so I've got two answers that have a cosine of negative a half at 120 and 240, but only one of those lies in the right range. So 120 is too small, so it's going to have to be the 240 degree one that they're after there. So it's 240. Question 26. B is 2/3 of C. 5a is 4c. Work out the ratio of a to b to c. Give your answers in its simplest form where a, b, and c are all integers. Okay, so we've got one equation in a and c, and another equation given as a written thing. But anyway, I can convert that into equation. B is 2/3 of c, so b equals 2c over 3 then, isn't it? Now what? Work out the ratio of a to b to c. A to b to c. Let's take the 5a equals 4c to start with. Well, if b is equal to 2/3 of c, or b equals 2c over 3, then I can rewrite that and I can say that 3b then is equal to 2c. Okay, so we've got two equations in B and C and A and C, and we want to write those as ratios. Now this is getting quite a common thing in exams, having to take an equation and rewrite it as a ratio between two things. And students do struggle a little bit about these. Let's take this 3b equals 2c1. Now I'm going to rewrite it. I'm going to cross multiply that c and that 3, and then I'm going to rewrite it as b over c equals 2 over 3. Okay, hopefully you're able to rearrange it that way. So if I take b and divide it by c, I'm going to get 2/3, and that's the easiest form really to convert into a ratio. So if b divided by c is equal to 2 over 3, then the ratio of b to c is 2 to 3. So if b is 2, then c is 3. We do the same thing with the other one. 5a equals 4c. So I start with 5a equals 4c, and I rearrange it the same way. So cross multiply that c down there, cross multiply that 5 down there. I'm going to get a over c equals 4 over 5. In other words, the ratio of a to c is equal to 4 to 5. Okay, so that means if c is 5, then a is 4. Now we want to get a ratio of all of these together. So can we find a common multiple? I need to find a kind of a common multiple of this number here I already found and this one. So 3 and 5. If I make it 15, So taking this 2 to 3 ratio and then multiplying it up by a scale factor of 5. So that, and that by 5 as well. That is going to give me 10 to 15 is the ratio of B to C. And I do the same thing here. So if I take this ratio and I multiply it up by 3 and I multiply it up by 3, then I'm going to get A to C is in the ratio of 12 to 15. Then I can take this 12 that I've got here and I can write it up here then. It's going to be 12 to 10 to 15 then, isn't it? Does that cancel down? Nope. That's kind of how it is. So I've got the ratio of A to B to C to be 12 to 10 to 15. Question 27a. Joe wants to work out the solutions of x squared plus 3x minus 5 is equal to 0. She says the solutions cannot be worked out because x squared plus 3x minus 5 does not factorize to a form of x plus a, x plus b, where a and b are two integers. Is she correct? Well, she's right insofar as it doesn't factorize, does it? I mean, if you look at minus 5, then the only factor pairs for minus 5 you're going to get are 1 and minus 5 or minus 1 and 5, and neither of those pairs adds up to 3. So it's not going to factorize, but that doesn't necessarily mean that there are no solutions. And you should all know that if you can't factorize, then plan B is to use the formula, which is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we can only say, well, I mean, the only way that that wouldn't work out is if the determinant part here is less than 0. So if that part there is a negative number, then we've got a problem. Then we can't find any solutions. But is that the case here? What is b squared minus 4ac? B squared minus 4ac, is that a positive number? B is 3, isn't it? So that is 3 squared. 3 squared minus 4 times 1 times minus 5. So, which is 9 subtract 4 times negative 5 is plus, isn't it? 9 plus 20, which is 29. So that means you could evaluate it then, because you could find the square root of 29, and then you can add and subtract that from minus b and divide it by 2a and get two solutions. So as long as this determinant part, this b squared minus 4ac, is a positive value or 0, you are going to get solutions. So you're not going to get nice solutions, that's why it doesn't factorize, but you are going to get solutions. So as b squared minus 4ac is greater than 0, there are solutions which you could find with the formula. Now notice it isn't actually asking me to find them. I just need to give a reason. So is she correct? No, she's not correct. Right, without expanding any brackets, show how to work out the exact solutions of a 9 lots of x plus 3 all squared equals 4. Okay, so how would we work this out without expanding any brackets? Well, rather than expanding the brackets, we can first of all divide by 9. So we'll take the 9 lots of x plus 3 all squared equals 4. First, let's cross multiply that 9 to the other side. So we're going to get x plus 3 all squared equals 4/9. Then if we root both sides, take the square root of x plus 3 all squared, I'm going to get x plus 3. And square root the other side, then it's going to be plus or minus. Square root of 4 is 2, square root of 9 is 3, it's going to be plus or minus 2/3. And then take the 3 to the other side, I'm going to get x equals minus 3 plus or minus 2/3 as a solution. So what are the solutions then? I'm going to get 1 when I add 2/3 to -3, and 1 when I take 2/3 away from -3. So x is going to be equal to -3 minus 2/3, which is -3 and 2/3, or x equals -3 plus 2/3, which is going to be -2 1/3. Question 28. Simplify the square root of 80 plus the square root of 2 and 2/9. Give your answer in the form of a root 5 over b, where a and b are integers. Fun. Okay, so root 80. Now, if I take 5 out of 80, 80 is 5 times 16, isn't it? So root 80 is the same thing as root 16 times 5. And I've got plus 2 and 2/9. So that's a mixed number, isn't it? What's that as a top heavy fraction? 2 times 9 is 18, plus 2 is 20. So that is the same thing as 20 over 9, all square rooted. Okay. So that first one, root 16 times 5, I can break that up into two different roots. The root of 16 times the root of 5. The root of 16 is 4, so that is 4 root 5. And on the other side, I can split that up into two roots. I can say that is the root of 20 divided by the root of 9. So that is the root of 20. The root of 9 is 3, isn't it? So it's that. So I've got root 20 over 3. Is that helping me? Okay, now 20 I can make to be 4 times 5, can't I? So if I leave that one for now, 4 root 5 plus the root of 4 times 5 instead of root 20. Then I can break that up into two separate square roots, and the square root of 4 is 2. So that's going to leave me with 4 root 5 plus 2 root 5 over 3. Okay, so we're almost there. So what can we do about this fraction on the left? If I want to put this over a common denominator, if I take 4, if I multiply top and bottom by 3, it's 4 over 1 at the moment. So if I multiply it by 3 by 3, then I'm going to get 12 root 5 over 3. So that is equal to 12 root 5 over 3 plus 2 root 5 over 3. So now I've got two fractions with the same denominator, so I simply add the numerators together. So 12 root 5 over 3 plus 2 root 5 over 3 is going to be 14 root 5 over 3. So it's in the form of a root 5 over b now, isn't it? Where a is 14 and b is 3. Question 29. Here are sketches of two graphs. I've got graph A and I've got graph of y equals x squared minus 1. The graph of x squared minus 1 is translated 3 units to the left to give graph A. The equation of graph A can be written in the form y equals x squared plus bx plus c. Work out the values of b and c. So the graph of y equals x squared minus 1 is translated 3 units to the left to give graph A. Okay, so if I take a function f of x and I translate it 3 units to the left, that is equivalent of taking my value of x and adding 3 to each value. In other words, where I see x in my equation, I'm now going to have x plus 3 instead. So in the equation y equals x squared minus 1, I'm now going to have y equals x plus 3 all squared minus 1. So the equation then is y is equal to, so where I see x, I'm going to write x plus 3 for my translation of 3 units to the left. And the rest is the same. So x squared minus 1 becomes x plus 3 all squared minus 1. Okay. Now I need to rewrite that in the form of ax squared plus bx plus c. In other words, I need to multiply out this bracket. So I can either double it up like that or remember the identity. A plus b all squared is equal to a squared plus 2ab plus b squared, which tends to be the way that I do it. I just remember that identity so I know what to do with these brackets when I multiply it out. So in other words, you get your first term squared, you get your two terms multiplied together and doubled, which is 6x, and then you get your last term squared, 9. So I get x squared plus 6x plus 9, and then I've got my minus 1 from before, which gives me x squared plus 6x plus 8. So comparing that with the form at the top, x squared plus bx plus c, so b is 6 then, and c is 8. Part B says the graph of y equals x squared minus 1 is reflected in the x-axis to give graph B. Work out the equation of graph B. Okay, so when we reflect in the x-axis, our equation f of x becomes minus f of x. Okay, so when you reflect in the x-axis, the y value will switch signs, won't it? So it's minus f of x. So work out the equation of graph B then. So if I take that equation, f of x equals x squared minus 1, and write a minus sign in front of it, then I'm going to get y is equal to minus x squared minus 1. So removing the brackets, I'm going to get y equals, it's going to be minus x squared minus 1, or 1 minus x squared. There's another way of writing it down. Okay. Advertisement break. Hopefully you are able to use this past paper to identify any topics that you still need to focus on for your exams. It's best if you do some focused revision around these topics between past papers, and this series of videos will help you do just that. They are based on the AQA topic tests, including key topics like trigonometry, Surds, indices, and a whole lot more. Click on the card above to go to the playlist. I'm adding to this collection all of the time, so if the topic is you're looking for is not yet covered, it soon will be. So subscribe below to make sure you don't miss out on any of these uploads. Right, back to the maths. Question 30, show that the exact value of cos 30 times tan 60 plus sine 30 is an integer. Okay, now again, these involve the exact trig values that you need to remember. I did mention earlier you need to remember the sines, cosines and tangents of the angles 0, 30, 45, 60 and 90. Okay, so I'll just pull it up on in a little table here for you to have a look at. So we can see from the table that the cosine of 30 is root 3 over 2. I'm multiplying that through by the tan of 60, which is root 3, plus the sine of 30, which again from the table is a half. Okay, so now unless you remember all those values, you are going to have no chance at all with this question. So you must memorize this table. It's not quite as hard as it at first looks, because you'll notice that the sines and the cosines is the same list written backwards, and actually tan is the sine divided by the cosine if you ever get stuck with that one. So really you just need to remember one of the lists and you can generate the other two. But whichever way you do it, you need to be able to remember what these are. Okay, so now I've got them written down, I've got an outside chance to be able to answer the question. So I need to show that it's an integer. Okay, so, well, that's not very hard. Root 3 times root 3 is 3, isn't it? So that's 3 over 2 plus a half. And what's 3 over 2 plus a half? That's 4 over 2, which is the same thing as 2. So it was super easy once I remembered or knew what those values were to start with. Okay, job done. Paper done. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.